Here we are going to find the derivative of the function x is equal to t squared cosine squared t plus square root of t sine squared t. So the first thing we're gonna do is differentiate summands separately and pull out constant factors. So it'll be like this: x prime equals d over dt t squared cosine squared t plus d over dt square root of t sine squared t. After separating the summands, we are going to apply the product rule, which states that d over dx uv is equal to u dv dx plus v du dx. And so, applying the product rule, we are going to get x prime t squared times negative 2 cosine t sine t plus cosine squared t 2t plus square root of t 2 sine t, which is the derivative of this, plus sine squared t times 1/2 t raised to negative 1/2, which is the derivative of the square root of t. Simplifying this, we are going to get negative 2t squared cosine t sine t plus 2t cosine squared t plus 2 square root of t sine t plus sine squared t all over 2t raised to 1/2. This, I think, is the simplest form. Therefore, this will be our final answer. Alright, so for set C, we are going to differentiate x equals log base 6 of x cosine x. So the first thing we're going to do is know the formula, which is d over dx log base a of u is equal to du over dx all over u ln a. So after knowing the formula, we proceed. Y prime, we are going to differentiate x cosine x by using the product rule, which is d over dx uv equals u dv dx plus v du dx. So applying this rule, we are going to get x negative sine x plus cosine x 1, which is the derivative of x cosine x. And copy x cosine x based on the formula and ln 6 So if we simplify this, we are going to get negative x sine x plus cosine x all over x cosine x ln 6. This is the simplest form, therefore, this will be our final answer. Alright, so for the last set, we are still going to find the derivative of a function, which is y equals 5e raised to hyperbolic cotangent x plus 1 minus ex. So, we are going to pull out constant factors and differentiate summed separately. Like this. 5, which is the constant, we're going to pull that out. Multiplied by d over dx e raised to hyperbolic cotangent x plus 1 minus d over dx e raised to x. So the derivative of these, we are going to use exponential rule, which is d over dx e raised to u is equal to e raised to u times du dx. Applying this rule, we are going to get e raised to hyperbolic cotangent x plus 1 times negative hyperbolic cosecant squared x plus 1, which is the derivative of this, minus ex, which is the derivative of ex as well. So if we simplify this term, we are going to get negative 5 e raised to hyperbolic cotangent x plus 1 hyperbolic cosecant squared x plus 1 minus ex. And this, I think, is the simplest form, therefore this will be our final answer.